Hello and welcome to the closeout video for our final milestone for the Conway tooling catalyst proposal. So we're just gonna go on to the evidence. So first thing we need to show, of course, the code implementing the Plutus v3 type support. So for the reading side, so that's the kind of Haskell, pure Haskell Plutus side, that's the Ply core as we call it. And as you can see, there's all the v3 instances for all the most common types that are applied as script parameters. And this is the, as I said, the Ply core side. There is the Ply Plutarch side. This is the Plutarch types. So there's all the v3 Plutarch types. And of course, the documentation for those types is attached to the Haddock itself. So the next one we have is updated code for encoding into CIP57. So on the Haskell side, we have this schema description type, which is basically a simplified version of the CIP57 schemas. And we have, of course, the JSON encoding implemented here. That's the 2 encoding, and this is the parser side. So there is the main grunt of the work. And then we have on the Plutarch side, essentially the helpers that will help you to convert these Plutarch types into the schemas that you need. And so here we have, all the types in the documentation for those types to kind of guide you to how to get these Plutarch types encoded into schemas. And in fact, I can show an example here which does exactly that. So here we're actually using this script called nftmp. And again, this is, you can also see it in example.nftm. It's a Plutarch script. And really we're using the helper functions that is exported from Ply Plutarch to essentially get the schemas for all the Plutarch related types and make a blueprint out of it. And again, the blueprint types are from Plutus TX themselves, so there is ample documentation on how to make these blueprints. What I show in this repository and in its documentation is really how to leverage those existing Plutus TX blueprint using Ply Plutarch for Plutarch. And there's a bunch of screenshots for that code as well that I just showed. Now we also want to see the example for argument application. Of course, that's one of the main draws of Ply, that you can apply arguments, typed arguments, and this is one of them. This is actually a custom type that we just derived and gave it Ply support. And we also have this nftmp, which is, again, this is our custom Plutarch script, and we actually make this Plutarch script take our custom type parameter, which is this my parameter, and this is how you apply in Ply. So we have the test suites as well. There's screenshots for it, but I'll just show the test suites passing in a bit. But the test suites are in these two directories here. So this is all the tests for Ply core. This is in Ply core/test. There's property tests for PlyArg, and there are unit tests for round trip encoding, decoding for the schemas themselves. And on the Plutarch side, we actually have tests for sort of the correspondence between Plutarch types and Ply types. So there's all those as well. And let me just go ahead and run all the tests. Whoops, it's Ply core test. And I'll also run the Ply Plutarch test after it's done. Okay, there you go. All tests pass for that. Let's run this one as well. Sorry, I'm not sure why it's rebuilding. It rebuilt a couple minutes ago. Anyway, there's all the tests passing. And we are gonna go to the example for deriving schema completely painlessly, completely generic for user-defined types. And here it is. So we define the Haskell type for our script, as I was talking about earlier. This is, of course, the Plutus TX kind of helper for making it data encoded, and this is all you need to derive PlyArg. In fact, if this wasn't template Haskell, you could just write derive any class PlyArg here, but because template Haskell means that definition order suddenly matters, So unfortunately PlyArg has to be down here because PlyArg has some dependencies on the type classes that this derives. So yeah, that's the only reason that it's all the way down here. Otherwise it could just be here in the derive any class. So that's how you do it for the Haskell side. Now you also want to make sure that you have the corresponding Plutarch type. So I have that in our Plutarch script definition itself. So this is the Plutarch script NFTMP that I was talking about before. This is the Plutarch type that corresponds to our my parameter custom Haskell type, and this is all you need to establish the correspondence on the Ply side, on the Plutarch side. So again, just 2 lines, everything is generically derived for you. Okay, finally we've got the new user guide. This is just a README, and it has a bunch of links to kind of point you to where you need to be to look at what you need to do. This is largely what I'm going over as well. And of course the final closeout video is what I'm recording right now, and the final closeout report will have it linked very soon when we submit all this. Thank you. This is just an addendum to the main Fly demo. This will be a brief showcase of the CIP57 decoding functionality implemented in PureScript. This was also a part of our milestone deliverables, and this is implemented in our PlyCTL repo, which will be linked in our report. So in that repo, we have functions to read the CIP57 blueprint into a PureScript type, and any off-chain backends implemented in PureScript, such as CTL, can implement functionality around said type to provide rich type scripts. So here I have the same blueprint file I used in the original demo. I'm going to use the provided functions to read this blueprint as a PureScript type. So let's go on ahead and get into the REPL. I'm just going to import the functions for reading blueprints that we have implemented, and just go on ahead and read the blueprint. Okay, so as you can see, the blueprint was successfully read, and we have this PureScript interpretation of the blueprint. This is just a simple show instance of the actual PureScript type, but you can see most of the structural details here. And that concludes the addendum of the demo. If you have any questions or comments, please feel free to reach out to MLabs. Thank you.